Hey guys, welcome to Safi Mixed. In this video, I talk about the importance of vector notation and will answer the question, why do we study vectors in physics and in mathematics? In other words, why do we give such an importance to vector notation or vectors while studying physics and mathematics? So before coming to the answer of this question, I want to let you know about the inventor of modern notation of vectors. In general, the idea of vector notation was born in the first 2 decades of 19th century. However, the modern notation that we use in physics was introduced by William Gibbs of Yale University. Now let's turn our attention to the answer of the main question. The modern notation of vector helps us to put the laws of physics in a very compact and more understandable way. For example, prior to the modern notation of vectors, the Newton's second law was used to be expressed in the following form. It is f sub x equals m times a sub x, and f sub y equals m times a sub y, and f sub z equals m times a sub z, where f, m, and a respectively represent force, mass, and acceleration. That is, the single law was used to be expressed in 3 different equations, one for each component of force along the 3 axes of Cartesian coordinates. However, we now know that force in the modern notation can be expressed in the form of F equals f sub x multiplied with unit vector I plus f sub y multiplied with unit vector j and f sub z multiplied with unit vector k, where unit vectors I, j, and k represent the direction of x, y, and z axes of the Cartesian coordinates. So if I substitute the values from equation A, B, and C into this one equation, I can write f equals m times a sub x multiplied with unit vector a plus m times a sub y unit vector j plus m times a sub z unit vector k. Since every term in this relation carries m, I can take the m common from them and can rewrite the right side of this equation in the form m times a sub x I plus a sub y j plus a sub z k. And now we know the quantity inside the brackets is in fact the vector representing the acceleration, so I can replace the quantity inside the bracket with acceleration vector and can put the equation into the form f equals ma. That is, the vector f equals mass times vector a. So you see now, the vector notation enables us to write Newton's second law in a more understandable and compact form. Besides this important property of modern notation of vector of putting equation in a simplified form, vectors are closely related to the fundamental ideas of symmetries. This aspect of vectors gives insight into the possible forms of unknown laws of physics. Furthermore, vectors are invariant under rotation. The rotational invariance of vectors greatly simplifies the forms of relativistic equation through the concept of relativistic for vectors. So these are the different reasons we study vectors in mathematics and physics. At the end, I would like to remind you to please hit the like button on the video and subscribe to Safi Mixed. Thanks for watching.